Hello, this is Miss Park, and this is one of a series of videos on factoring. Okay, and so let's do a quick definition or a quick explanation of what factoring is. So we know about multiplication, okay, and factoring is backwards of multiplication. So for example, if I said 4 times 6 is equal to 24, that would be multiplying. Factoring would be, okay, I have 24. How can I write it as something times something? Right? So there's different ways to factor 24. You could say 24 is equal to 2 times 12. You could say 24 is equal to 3 times 8. You could say it's equal to 6 times 4. There's lots of different ways you can say it. And all of these would be factored, a factored way of writing 24. It's written as a multiplication statement. But all of these examples can actually be factored further, because if you look at, let's say, for example, 6 times 4, the 6 can be factored into 3 times 2, and the 4 can be factored into 2 times 2. So really, this last way of writing 24, 3 times 2 times 2 times 2, none of those numbers can be factored anymore. So this one is actually called fully factored. And that's what we're going to do in our class, except we're going to do this with algebra. We're going to take an algebraic expression and write it as something times something. So that's what factoring is writing an expression as something times something. Oops. Okay, only we're going to do this with algebra. So hang tight, here we go. The first kind of factoring we'll do has to do with common factor. So I'm going to do this. That's what this video will be about. Okay, so with common factoring, it looks like this. Back in grade 9, we used to have distribution. So remember, there's multiplication and then there's factoring, which is the opposite. Okay, there's two different things. So back in grade 9, we used to have the distribution. So it used to look like this: 2 times x plus 5. And we would multiply, we go 2 times x and 2 times 5, and we get 2x plus 10. With factoring, we want to write 2x plus 10, but go backwards and say, so that equals to what times what? What can go into the brackets? If we used an area model, remember the area models I showed in the expand and simplify video, here this is 2 times x plus 5. We can do the inner areas, so the first rectangle is 2 times x, and the second rectangle is 2 times 5. And so then I get this is 2x plus 10, right, using the area model. If I did it with this question, it would be, well, the inside is 2x plus 10. That's the area. So what do the dimensions have to be to get 2x plus 10? So that's what factoring is. What are those dimensions? What's the something times something that's going to give me this expression? So we look carefully at the expression and we look to see, is there something in common, greatest common factor, a greatest common factor of 2x and 10? So the greatest common factor is a number that divides evenly into 2x and into 10, which means when you divide by that number, you don't get any remainders. And it looks like the greatest common factor is 2. So 2 will divide into 2x and 2 will divide into 10 and not leave any remainders, and there's no bigger number. So what we do then is we say, okay, if the greatest common factor is 2, I'll write my greatest common factor out here. So that's a 2. And now to figure out what goes on the other side, I'll break this into its 2 parts. And I'll say this: the first rectangle has an area of 2x. One dimension is 2. So then what's the other one? Well, that has to be x. The second rectangle has an area of 10. One dimension is 2. So what's the other one? Well, it has to be a positive 5. So now we can write 2x plus 10 is equal to 2 times x plus 5. We have factored it, which means we have written it as something times something. Okay, let's do another one. So let's do 4w minus 24. Okay, so if I was to do an area model, my inside is 4w minus 24. I'm looking to see what's a common factor. a 4w, and negative 24. So the greatest common factor seems to be 4. So I'm going to put 4 as one of my dimensions. Split this into two parts. The other dimension of the 4w rectangle must be w. And then for the negative 24, this must be negative 6. So I have 4 times negative 6 is negative 24. Okay, and so then we can write 4w minus 24 can be factored into 4 times w minus 6. All right, so there's lots of factoring methods. This one is called the greatest common factor method, because I'm going to do a few more examples. Suppose I have really complicated looking expression. So suppose I have 10x squared y plus 25x squared y squared minus 20x, I don't know, what do we want? Okay, 20x, that's it. So let's say it looks like this. And I want to take out a common factor. I want to find a common factor. So what we're going to do is we're going to look at the number part, okay, the 10, the 25, and the 20. And what is the largest number that can fit into all of those, right, without a remainder? So it'll divide into all of those without a remainder. So 10 doesn't work because 10 doesn't go into 25. So the biggest one I can find is a 5. So I'm going to write that out there. And then that's going to be one of my factors. So if I was to do an area model, this is 10x squared y plus 25x squared y squared, and I ran out of room, so I'll make the box bigger. And then minus 20x. So I know that 5 is the biggest number. But besides the 5, besides the number part, there's also variables, right? So there is the GCF is 5, but it's actually more than 5 because with the variables, I see that there's an x in every term. So I can actually factor out an x. And so my GCF is actually 5x, not just 5. So I'm going to put 5x over here. Now the y's are not a common factor because there is no y in that last term. So my largest common factor is going to be 5x. So in my area model, I'm going to now split this into the three parts, and I'm going to see what do you need to multiply by to get that inner area. So first one, inner area is 10x squared y. One of the dimensions is 5x. What does the other dimension have to be? Well, it needs to have a 2, so I can get the 10. There's already one x in the 5x, so I need another x to get an x squared. And I also need the y because there was no y in the other dimension. All right, and then here I have plus, okay, what do I have to multiply 5x by to get 25x squared y squared? I have to multiply by 5 to get 25. I need another x, and I need a y squared. And then the last one dimension is 5x. The area is negative 20x. So what do I need to multiply 5x by to get negative 20x? That would be minus 4, negative 4. And so this tells me that 10x squared y plus 25x squared y squared minus 4 can be written factored as 5x times 2xy plus 5xy squared minus 4. Okay, this is factored. And remember what factored means, it means something times something. So now, back to without the area model, I'm going to do the same thing, but it's a little bit, you kind of have to do this in your head. 5x times what is 10x squared y? So when you think about it, really, if I said to you, let me go in a different color over here. If I said to you, 24 is equal to 4 times what? How would you know what goes in there? Right? Well, if you know your times tables, you know that a 6 goes in there. But if you didn't know your timetables, so what if I made like a really big, like some other number like 243 is equal to 3 times what? Right? How would you know that number inside? Well, that number inside is simply what you get when you have 243 divided by 3, whatever that is, in the calculator or in your head, that's 81. So that's how you know what goes in there. It's a division because you're doing the multiplication backwards. So let's go 10x squared y divided by 5x. So the 10 divided by, here, let me write this unnecessary to show step, but just for the first example. What goes in there is what you get when you divide what's on the inside by the 5x. And then in here, that's 25x squared y squared divided by 5x. And over here, 20x divided by 5x. Okay, so we're never ever going to write this step unless you really need it. Okay, and so that's going to be 5x times, and let's reduce each of these fractions. 10 divided by 5 is 2, x squared divided by x is x, and then we have a y. 25 divided by 5 is 5, x squared divided by x is x, and then we have y squared. And then negative 20 divided by 5 is negative 4, and the x's become just 1. And that's it, and that's factored. Right, this is factored. So whether you use the area model or you don't, if you're just going to use a straight up algebra, it's the same thing. You're trying to find the two terms that multiply to give the term in the original question. Let's up the difficulty here, and let's do this. What if I had 4 times x plus 5 minus 3x times x plus 5? Now, if the question said to expand and simplify, I would do all this and expand and all of that, okay? But I'm not going to ask you that question. I'm going to ask you to factor. Okay, so the question is going to be factor fully. That's the question. So factor means write as something times something. It does not mean expand. It's the opposite of expand. Okay, because expand actually does the multiplication. Factoring says write it as a multiplication. So I'm going to write here opposite of expand. So we're not going to expand, even though we think that's what we should be doing. We're not. Look for a common factor. Do you see something in common? Do you see something that is appearing more than once? Right? You should notice this x plus 5 and this x plus 5 appears more than once in the expression. So what we'll do is we'll say, that's just x plus 5 times a bunch of stuff. Okay? The first part divided by x plus 5. So 4 times x plus 5 divided by x plus 5 leaves me with just a 4. And negative 3x times x plus 5 divided by x plus 5 leaves me with negative 3x. Now it's factored. It's x plus 5 times 4 minus 3x. What do you think? All right, let's do one more, and that'll be the end. So common factoring. A squared plus AB plus 5 times, let's go A plus B. Okay, so this is a challenge question. All right. Don't expand. We're going to try to common factor. All right. There's nothing we can do right now. We don't see anything in common anywhere. But if you notice this first bracket can be factored because from A squared and AB, there is a common factor of A. What would have to go in the bracket? Well, A squared divided by the common factor leaves me with an A. AB divided by the common factor leaves me with a B. So I can write A squared plus AB as A times A plus B. You can double check that in your head because if you did the distribution, you would see it would be the same as the line above. Okay, and so now I'm going to complete this. Plus 5 A plus B. Now, do you notice something that's appearing more than once? Yes, this A plus B. So A plus B becomes my common factor. So now the greatest common factor is A plus B. So that's going to sit outside. And how many of them do I have? Well, let's see. The first part is A times A plus B. I already have the A plus B, so there's only A left. The second part is 5 times A plus B. I already have the A plus B sitting outside, so it's just plus 5. And now it's factored. Okay, so that was a challenge question. So when you do your practice, you will start with sort of simpler ones like this. Okay, then we'll add more terms and maybe more exponents, and then you'll move into the more challenging ones. Okay, so that is common factoring. There's lots of other kinds of factoring that we'll be studying, so look for the other videos. Thank you.